Today we'll be talking about similar figures, solving using proportions. In the back of your foldable you have 3 vocabulary words that we need to define. The first one is similar. Figures that have the same shape but are not the same size. These could be 2D shapes, they could be 3D shapes. Corresponding sides. Sides that are in the same relative position on the 2 different shapes. Corresponding angles. Angles in the same relative position on the 2 different shapes. Now open up your foldable and we'll be the example on the top left. And the question is, are these 2 figures similar? We're going to set up a proportion and use cross products to decide whether these 2 figures are similar. So words, ratio, info looking for. Now, all the angle measurements indicate that these should be similar figures, but we need to check with the corresponding sides to make sure that they truly are. So the words that I chose to use are big and small. So the big triangle over the small triangle. So I picked 16 from the big. The corresponding side on the small would be 8. Then I go back to the big and I pick another corresponding side, which is 30. And the corresponding side on the small one would be 15. Now I'm going to use cross products. So that means 15 times 16, which is 240, and then 8 times 30, which is 240. So, did I calculate the same answer? If my answer is yes, then these 2 figures are similar, in which these case they're proportional and that makes them similar. Okay, the example right below these 2 rectangles. So now I know opposite sides of rectangles are equal, so that means this side is 36 and then these 2 pieces are the same, so I know this side is 45 and 18 and 25 are still in the same corresponding place. So words equals ratio given equals the info that I'm looking for. So again, I chose the words big and small, so I chose 1. The corresponding side would be 36 on the small one, 25 on the big one, 18 on the small one. I'm going to use cross products again. So I'm going to do 45 times 18, which is 810, 36 times 25, which is 900, and did I calculate the same answer? My answer is no, so these 2 shapes are not proportional because my cross products are different. Now, even though all my angle measurements are the same, it does not automatically make them similar. I had to verify if the corresponding sides were the same. Right, now we're going to use proportions on similar figures to find a missing piece. And in this case, we're going to be looking for n. So, words, the ratio given, the info looking for. So, again, big over small. So I chose 15 off the big one. The corresponding side would be 7.5 on the small one. Then since I'm looking for n on the small one, I know I need to use 8 on the big one and then n on the bottom. Now I'm going to set up an equation and I'm going to solve. Again, I'm going to do it using cross products. So I have 15 times n equals 7.5 times 8. So I'm going to combine and I get 15n equals 60. Now, one-step equation, I need to do the inverse operation of multiplication, which would be division. So I'm going to divide both sides by 15, and n would be 4. Alright, we're going to look at one more example. Okay. You're probably thinking there isn't 2 shapes there, but you'll see that there is a smaller triangle inset into the larger triangle. So that's what I'm going to compare. I'm going to compare the big to the small. Okay, so my big measurement, so I need this piece right here. So this piece to this piece was 3, and 3, and then D to B was 2. So that's where I get the 5, that's over here. And then my little piece back on the small one was 3. And then my big piece down here was 4.
And then on the smaller one, it's x. So again, I'm going to set up an equation. I'm going to solve. So I have 5 times x equals 3 times 4. Combine, 5x equals 12. So inverse operation, I have to do the opposite of what's there. So I'm going to divide both sides by 5. And 12 divided by 5 would be 2.5. So this piece, x, equals 2.5.